Hi. So this question says a football has been kicked at 10 meters per second along a line that has a 30-degree angle of elevation above the horizontal. What is its horizontal component of velocity? So now we're dealing about with components. And the first thing we've got to do is visualize. So when we're dealing with components, we think about axes. And in this case, I'm going to think about a horizontal axis. And I usually have two orthogonal axes. That means two axes that are at 90 degrees to each other. So I can have a vertical axis. And this football has been kicked. So I'm going to just show the vector. Actually, I'm going to just step back a bit. And there's something I want to emphasize to you. And that is the most common mistake is that people draw all their vectors at 45 degrees no matter what the angle is. And I think it's really important to have, if it's less than 45 degrees, you draw it as less than 45 degrees. If this were more than 45 degrees, I would draw it as more than 45 degrees because there's a big angle and a little angle making up the right angle for me. But if you draw things at 45 degrees, there's only two angles and you can't tell one from the other. So I think it's important to try to draw your diagrams, especially when you begin, reasonably to scale. In fact, I recommend to my class that they get a little protractor, and when they begin, they use a protractor to draw their angles. Um, so there's its direction. The language is 30-degree angle of elevation above the horizontal. And that's, if you like, physics speak. It's a common phraseology. And the idea is that there's my angle of elevation. And this is above, it's up the page from the horizontal axis. I could have 30 degrees below the horizontal axis, 30 degrees angle of elevation below the horizontal axis. So language is important in these things, and it's the more time you spend reading the book and going through the notes, the more you become familiar with the common language of this material. The actual length of this, the actual size of the vector is 10 meters per second because it's a velocity vector. Let me make this a little bit longer so I can make my diagram a little bit clearer. And the game we're playing is we're trying to find the horizontal component. I imagine a light above a wooden arrow, and I ask myself how long would the shadow be under the arrow on the ground, and that's basically what I'm doing here. I'm looking for this arrow. It's in the x-axis direction, and I want to know how long it is. Well, I projected this end of the arrow down, and that was 90 degrees. So this is a relatively simple, but it is a simple right angle triangle. So I can simply say, oh, my uh, uh, cosine theta is equal to adjacent over hypotenuse. So that means cosine 30 is equal to the adjacent, which is what I want. Let's call this x, is equal to x over hypotenuse is 10. So my x component is equal to 10 cosine 30 degrees. So my x component equals 8.66 meters per second. So there's my answer. A few things to talk about before we leave. It would be really good to get to the stage where you don't necessarily need to write down these first lines. Personally, I'd like you to get to the stage where you could look at this and go, oh yeah, x equals 10 cosine the angle. Because this is going to become just an incidental part of what we do in problem solving. The second thing is that people sometimes make mistakes on these, not because they don't know their trig functions, but because they don't have their angle sorted out. I remember as a student not realizing that the original vector was always the hypotenuse when you take components. It's always the longest line. And so I would sometimes get completely the wrong answer because although my setup was okay, although I had a decent diagram to begin with, for various reasons, most typically that we weren't working on the horizontal, we were working at some angle. For various reasons, I would then draw a line where the right angle was on the head of the vector. And so I would produce a component which was the hypotenuse. And that is impossible and never do it. So learn the lesson. The original vector is always the hypotenuse of your triangle when you're taking components. And draw your diagrams carefully and they'll go well. So there we have it.